Hello, friends, and welcome back to Bartlett's Math Magicians. So, today's lesson is a little different than normal. So, we're not actually solving any equations, it's just a lot of vocabulary and a lot of information. So, it's important that you have your math notebook or a sheet of paper so that you can write some things down, or you can pause the video throughout and either take pictures or copy things down. It is completely up to you because the questions that you're going to be answering are just based on like knowledge of characteristics. So we're going to be talking about polygons, and we're going to talk about quadrilaterals and triangles. So I have the standards over here, 5.G.B.3 and 5.G.B.4. So if you're wanting additional resources past this video, either on YouTube or Khan Academy, I would definitely look up those standards for any of those other resources, because your resources don't have to always come from me, although the resources from me are direct things that would be exclusive to our class. So let's go ahead and get started. So we're going to first talk about polygons. So you're going to hear this word that I'm going to type in. This word called hierarchy. And the word hierarchy is basically like there's a hierarchy in families. So there's like grandparents, then children, and then children's children. And so that's a hierarchy, or kings and queens, then under them are prince and princesses. So a hierarchy is like a line, like a family tree, as I kind of like to refer to it as. And so you're going to see the word hierarchy on some questions, or you may hear the word hierarchy, and so that is what that means. And so we're going to talk about the top parent or grandparent of all of these shapes that we're going to be focused on, and that is polygon. Polygon. So if you see right here, it says polygon comes from a Greek word. The prefix poly means many, and gon, G-O-N, means angle. So it says polygons are two-dimensional shapes. They are made of straight lines, and the shape is closed. So you can see some examples. This is a straight side polygon. This would not be considered a polygon because it has a curve. So like a circle is not considered a polygon. Then they have straight lines, but the polygon is open. You see the lines are not connected. So a polygon is a two-dimensional shape. So you have different kinds of polygons. You have a regular polygon that has all angles and equal sides, and all the sides are equal. So you're thinking about your hexagons, pentagons, octagons, and then you have ones that are not always equal, and that would be like an irregular polygon. So we are going to focus on this little family tree. So this would be maybe a good time to pause the video and copy this family tree down, or take a picture of it. So we're going to focus right here for right now, this line of family tree. And notice that the family tree starts with polygons. So you could say like the polygons are like the main parents or the grandparents. And polygons have their own set of children, if you want to think of it like that. You have triangles, you have quadrilaterals, and you have other polygons. Other polygons being hexagons, pentagons, octagons, heptagons. That would fall under this category. We're not going to focus as much right there. We're going to focus right here, which is why I have a lot of information here. So go ahead and pause the video and copy this down. Okay, so let's talk about quadrilaterals. Quadrilaterals. Well, a quadrilateral, notice the prefix quad means four. So a quadrilateral has four sides and four angles. Four sides, four angles, and the angles add up to 360 degrees. So a quadrilateral has four sides, four angles, and the angles add up to 360 degrees. So then this page here, again, you may want to pause this on as you work and take a picture or copy this down. Here are the kinds of quadrilaterals, and I'm gonna be shifting from this screen to this screen. So notice that you've got trapezoid, and trapezoid has an interesting characteristic of its own. So sometimes there's a little bit of debate on what exactly is the definition of a trapezoid, but we're just going to follow the model with the standards and the information that I'm given to transfer to you. So notice that trapezoid, parallelogram, rhombus, rectangle, square. It starts from the most generic, all the way down to the most specific. So think of a family tree. If you have like great-grandparents, the great-grandparents have the children and then grandkids and then great-grandkids and all of that. If this is you, that means you have all of the characteristics of all of these. You have every characteristic of all the things that are above you. You have the characteristics of your parents. You have the characteristics of your grandparents. You have the characteristics of your great-grandparents. But it's not always the same from top to bottom, because the polygons are not always going to be in the quadrilateral part, because polygons also have triangles in them and other polygons. So thinking about most general all the way down to most specific, and from the bottom to the top, everything from the bottom has all of these attributes, okay? So that'll kind of make a little more sense as we get to talking about it. So let's talk about this screen. So we have a trapezoid. Now I've uploaded pictures, but these pictures are not just exclusively for that shape. There could be a different kind of example, but I just put the examples that we're used to seeing. So a trapezoid, here's a picture of a trapezoid. A trapezoid has at least one pair of parallel sides. And you notice it's got at least one pair of parallel sides. And remember, parallel lines are lines that never, ever, ever connect or intersect. Okay, so parallel, at least one pair of parallel lines or sides. A parallelogram, okay, notice parallelogram, opposite sides are parallel, so that means this side and this side are parallel. And this side and this side are parallel. So that's why it's a parallelogram. All of the opposite sides are parallel. Also, opposite sides are equal, or you may hear the word congruent, which means they are equal. So all of these opposite sides are congruent. So this side is equal to that side, and that side is equal to this side. So with that information, parallelograms are trapezoids, because a trapezoid has at least one pair of parallel sides, and a parallelogram has opposite sides are parallel, so it at least has one pair, so it falls under the category of a trapezoid. Now, if you go and research trapezoid definitions, you're going to get sometimes that it has exactly one pair, or sometimes it has at least one pair. We are following the inclusive model that it has at least one pair of parallel sides. So then we have a rectangle. So again, I'm starting at the most general, and I'm kind of getting a little more specific. So even more specific than a parallelogram is a rectangle. And notice, a rectangle has the same attributes as a parallelogram. Opposite sides are parallel, opposite sides are equal. But what makes a rectangle that unique rectangle, like what makes it a rectangle, thinking about what makes you, is that it has four right angles. So it cannot be a rectangle if the angles in the corners are not right angles, which are 90-degree angles. Okay, so we're kind of gonna look back here. So after parallelogram, it kind of splits out to a rhombus and a rectangle. Okay, so we've already talked about a rectangle. So a rhombus, the opposite sides are parallel and the opposite sides are equal. So it has the exact same characteristics as a parallelogram. It does not have to have 4 right angles, which is why it doesn't fall under the category of a rectangle, but it can have 4 right angles. And if it does have 4 right angles, and opposite sides are equal, it could be a square, which the square we know is the most specific of all quadrilaterals is a square. It has all of these characteristics, so it would be like the baby. It has all of the characteristics of the family. It has opposite sides are parallel. All the sides are equal. So because opposite sides are equal, a square has all the sides are equal, which obviously that means opposite sides. And then it has 4 right angles. So thinking about what is a square, rectangle, is a square, rhombus. So yeah, we can create some generalizations. I want you to go ahead and try to pause the video, and maybe you can determine some generalizations based on these attributes. One of the most common generalizations is that all squares are rectangles. That is a generalization because the square has all the attributes of a rectangle. I like to think it looks better from the family tree point of view, that a square is connected to a rectangle, and the square is the bottom, so that means it has all of the attributes of a rectangle. So a square is always a rectangle. A square is always a parallelogram. All squares are trapezoids. All squares are quadrilaterals. All squares are rhombuses or rhombi. I can't say the same about a rectangle. A rectangle is always a parallelogram. A rectangle, trapezoid, rectangle, quadrilateral, rectangle, polygon. But a rectangle is not always a square. It's only a square when all of the sides are equal. So again, it's a little bit of a mind shift, and it's kind of hard to keep these characteristics straight. So you're really going to have to try to look at these and study these and think of the generalizations. So think about some other generalizations. All squares are rhombuses, and sometimes it's spelled rhombuses or rhombi for plural. Are all rectangles parallelograms? So if you're trying to answer that, think about, does the rectangle have all of the characteristics of a parallelogram? It sure does. If you look at the family tree, the rectangle is below the parallelogram, so the rectangle has all of the attributes of a parallelogram. So yes, all rectangles are parallelograms. Now, all parallelograms are not rectangles because look, sometimes a parallelogram is a rhombus. And a rhombus does not have to have 4 right angles. So notice, like bottom to top, this is this, this is that, that is that. But it does not always work the same way, okay? All right. We're going to come back to this page right here. So based on the information that you have, I want you to try to pause this video and try to answer these questions, true or false. Okay? So the first one says a polygon is always a parallelogram. Is that true or false? So what you're asking yourself is, a polygon has all of the attributes or the characteristics of a parallelogram. So that family tree picture will be a great help. Is a rectangle always a quadrilateral? Is a rhombus always a square? A square always a quadrilateral? So go ahead and pause this video and solve true or false, and then we will discuss. Okay, so let's go ahead and discuss this. So a polygon is always a parallelogram. Well, let's look at the family tree. A polygon is not always a parallelogram because look, a polygon is what? Other polygons. A polygon is also a triangle. So a polygon is not always a parallelogram. It's actually the opposite. A parallelogram is always a polygon. So that is false. The next one is a rectangle is always a quadrilateral. Well, does a rectangle have all of the characteristics of a quadrilateral? Does it have 4 sides, 4 angles? And does it have angles adding up to 360 degrees? It does. So that is true. A rhombus is always a square. Well, a rhombus, if we remember, go back to your notes, a rhombus is not always a square. A rhombus just has to have opposite sides parallel and opposite sides are equal. It does not require a rhombus to have 4 right angles and all equal sides. So a rhombus is not always a square. It's the opposite. A square is always a rhombus. A square is always a quadrilateral. Yes, a square absolutely is a quadrilateral because a quadrilateral just has 4 sides and 4 angles, and a square has those attributes. So if you got all those correct, give yourself a pat on the back. All right, let's go for the next one. Go ahead and answer this question. Which statement is true? A polygon is always a parallelogram. A rectangle is always a quadrilateral. A rhombus is always a square, or a triangle is always a quadrilateral. So go ahead and answer this. Okay, so thinking, go through each one. Is polygon always a parallelogram? Okay, well, if polygon is the most general, it can't always be something under it. So that's not an option. A rectangle is always a quadrilateral. Well, a quadrilateral just has 4 sides and 4 angles, so the correct answer is B. A rhombus is always a square. That is not always true. And a triangle is always a quadrilateral. That should have easily been eliminated. A triangle has 3 sides. Quadrilaterals have 4 sides, so that's not true. Okay, so what I would like for you to do right now is I want you to look at these shapes and I want you to try to label them, all of the shapes that you think they are. So for example, we're going to start here, right here. If you said, okay, I know that's a square. Well, if that is a square, then it's also something else. It's also something else. So I'll give you a little bit of direction, a little bit of hint. So I know everybody's going to say, oh, this is a square. Okay, is it only a square? Is it something else? So I'm not going to give you all of them, but I will go ahead and kind of provide a little bit of help. So if square is the most specific, that means it has to have all of the attributes of every other one that has a line connected to it. So if it's a square, then it has to be a rectangle, right? So continue that on. If it's a rectangle, it has to be this. If it's this, it would have to be this. So I want you to do that for all of these and pause the video and do that, and then we will discuss some of them. Okay, so if you have unpaused the video, then we're going to talk about the rest. So we said this was a square, this was a rectangle. It's also a parallelogram. It would also be trapezoid, so just going up that family tree, which would then be a quadrilateral, which would then be a polygon. So again, if you didn't understand about including all of the names, you can go back and include all of the names. So if we look here, we should see, okay, there's not 4 right angles, so it can't be a square or a rectangle. But it does have 4 sides and 4 angles, so we know it's a quadrilateral. The opposite sides look like they're equal because these 2 are red, these 2 are blue. So we could say what? It's a parallelogram, it's a quadrilateral, it's a trapezoid, it's a rhombus, right? So you're kind of getting the hang of labeling the shapes. So if you didn't finish, go ahead and finish. The next video will be about classifying triangles and the attributes of the different kinds of triangles. So there is some independent work attached for this that is on the menu. So make sure that you do that. And again, if you have any questions, just let me know. Bye.